Now, let's take a journey through the development of forces and the laws that came about from a very intelligent man known as Isaac Newton. He was a great physicist and a mathematician who was once sitting under a tree and got hit by a falling apple. He then wondered, how did this happen? Then suddenly he came to an answer that force is acting on the apple downwards to the center of the earth, which he calls the gravitational force. Then there was a conclusion that all human exerted forces and that forces were acting on them as well. Now, as you can see in the picture, you have a blue, green, and red. Where it says that the blue line is the force of the weight on the body which is acting downwards toward the center of the earth. You have normal force on the body which is acting upward, which is opposite the downward force, and you have the frictional force, in this case static friction, which is parallel to the surface on the ground. And here bear in mind that friction means the slowing down or the resistance of motion. Where you see there is a black arrow, although the dot is not there, this arrow is just indicating the direction of motion. Now we come to Newton's laws of motion. Newton's first law of motion. As you can see, another name for Newton's first law of motion is inertia, where it says an object at rest will remain at rest, or an object in motion will remain in motion in a straight line at constant speed unless an external force is applied to it and changes its states of motion. Now, a perfect example of this would be a car driving on a road where the car's speed is constant and there is no external force acting on it to change its state. Another example would be a plane in the sky flying due north or due west, and the same thing for a ship in the ocean, which may be going due north or due west. And the next example, as you can see in the picture, will be a cup, a plate, or a candle on a table. Reason why? Because they are at rest and there is no external force that will change the state of motion. Now we move to Newton's second law of motion. Now it says that acceleration of an object depends on the mass and the size and the direction of the force acting on it. And it says that the more the mass, the harder it is to accelerate. The bigger the force, the more the object will accelerate. Now basically this is saying that the mass is inversely proportional to acceleration and that the force is directly proportional to acceleration. Out of the second law of motion came a formula which says F equals to m times a, as seen in the picture, which basically means F is force, m is mass, and a is acceleration. And through this formula we can calculate the force that a object produces, the acceleration a object produces, and also the mass a object produces. And keep this in mind, the more the force, the more the acceleration. Now we come to Newton's third law of motion, which is basically an action and reaction. Now, Newton's third law of motion states that when an object exerts a force on a second object, the second object exerts an equal but opposite force to an object. Haha, this may sound so interesting. Let's look at another example. Now, in the picture, you can see that there is a lady on a skateboard and she is exerting force on the wall. The force in which the object, the wall in this case, exerts back on her is enough to move her on the skateboard. This is a clear and very defined example of Newton's law of motion number 3. All these 3 laws and the discovery of force came out of just an apple hitting Sir Isaac Newton on his head. And bear in mind, there are many great discoveries which he has came up with. This is just a tip of the iceberg. Thank you for watching. This was done by Kemar Gale, Karima Bailey, and also Raquel Jarrett. Thank you and God bless you.